right, so this is lecture number 4 in the pressure series. And in this one today, we're going to be talking about local winds. In the last lecture, we talked about highs and lows on a weather map. We called them anticyclones for a high and cyclones for a low. And we looked at those squiggly lines that show pressure on a weather map called isobars. Today, in this section, we're going to talk about more local winds, things that you can measure happening on a beach. We're going to talk about sea breezes. We're also going to talk about land breezes, which are the reverse. And we're going to talk about something that either you've already mentioned in world cultures or will be mentioning, which are monsoons, and what those are and why they happen. So first, before we talk about the winds themselves, let's talk about how I measure a wind. There are two main tools that we use, and those are an anemometer, which is very much like a pinwheel in that it spins very fast when it's windy and not so much when it's not. And an anemometer measures wind speed, whereas a wind vane, which you've probably seen, there's definitely lots of these on barns, in farms in the area. Airports will have wind vanes and anemometers as part of their just weather monitoring systems. Sometimes you'll see these as wind socks that almost look like kites, but a wind vane will tell you the wind direction. And so that's very important for us to know because remember that pressure is air flowing from high to low. So if you know which way the wind is blowing from, you know where the high pressure system is, and it's where the wind is coming from. So we always name a wind, and this is important for the next winds we're going to talk about. You always name a wind for where it is coming from. The most common example I can think of for this, besides a sea breeze, which would come from the sea, is in the winter, we often get these things called nor'easters, and they tend to be big blizzards, and they are usually the result of cold air coming in from the northeast. So nor'easters are winds that come from the northeast. So let's talk about some of these winds. We are, in this lecture, going to talk about land and sea breezes first, and then monsoons. And in order to get a local wind, or a regional wind in the monsoons case, remember our saying. I'm going to keep saying it until it haunts you in your dreams. Pressure flows from high to low. So I need to find a way to get a difference in temperature, high versus low. And with local winds, this usually happens because of differences in temperature. So if you think about the last time you went to the beach during the day and you walk on the sand without any shoes, that's probably going to hurt a whole lot because land heats up really well during the day, whereas then you get in the ocean and it's nice and cool. And so cold sea, remember this relationship is inverse. So if I can get a cold ocean, if I can get the temperature to go down, I can get the pressure to go up. So I can have high pressure over the sea compared to warm temperatures over the sand, and therefore lower pressure. So we're going to talk about that, and I'm going to draw it out for you. So pressure flows from high to low. Now, I'm going to try to draw this nice and big on the whiteboard behind me, and I'm really hoping this works because I haven't had a chance to use my whiteboard yet. But if we were to draw a sea breeze, all right, for a sea breeze, you're going to need an ocean. You're going to need a beach. Now, as we just talked about, I'm going to need to find a way to make the pressure between the beach and the ocean different. So, during the day, the sand is incredibly hot. So I've got hot sand, which means that I have high temperatures. I'm going to write high T for high temperatures. And if the temperature is high, that means that the pressure is low. So I'm going to put a big old L right here on the beach for low pressure. And then for my ocean, it's going to be the opposite, right? Here, it's nice and cold. Well, cold temperatures have high pressure. So during the day, the ocean is my high. All right. So remember, in order to get a breeze to come through, pressure flows from high to low. So during the day, you'll get a nice breeze as the high pressure air over the ocean tries to reach the low pressure over the beach because of these differences in temperatures. Pressure flows from high to low. So this is a sea breeze, and it's happening because of the differences in pressure. This is an important thing. A sea breeze happens during the day. All right, so a sea breeze is during the day because of those differences in temperatures and pressure, and therefore sea breezes will happen until it starts to get dark. And then what we're going to do in class together is figure out, well, how do I get a land breeze, which is the opposite? But you can probably already figure out that a land breeze has to do because somehow I have to get the ocean to be warmer than the land so that the pressures switch. So I'm going to leave this up behind me, sea breezes. And I'm going to put up a drawing as well on Classroom for you, but this is essentially a sea breeze. I need to get the temperatures to be different due to the time of day. Here's just sort of a summary of what we just talked about. We've got a sea breeze due to the day, the land being a higher temperature. Higher temperature means lower pressure. And so there are these arrows kind of circulating back along the top here that you'll see. Those arrows that circulate back are just, well, now I've got lower pressure here because most of the air has moved to the beach, and it's just recirculating out to fill the lower pressure. So it's higher pressure down near the ground, but lower pressure down up near above. So you get this circulation system, so the air just keeps recycling. And so this is why when you go to the beach, it is always windy. There's always a breeze coming from somewhere at the ocean, just depending on what time of day it is. So that's a sea breeze. And as I said, we'll talk about a land breeze as well. The other regional, this is a much larger system of wind, but still not like half of the United States big. We're going to talk about monsoons, which are wind systems that change direction seasonally. The most common known monsoons, or talked about the most, are the ones in India. And they're a great example because India has monsoons during the summer and the winter, because it just depends on which part is warmer, the Indian Ocean or the Indian landmass. And so based on when the wetter temperature, when it's a wetter monsoon, that means that, as we talked about air masses, when the air mass is bringing water from the ocean, rather bringing air, humid air that formed over the ocean onto land, you'll get wet monsoons in the summertime. In the summertime, just like the beach and the ocean, right? At the sea breeze, the land is really, really warm and therefore low pressure, and the ocean is really, really cold and therefore low pressure. Sorry, high pressure. High pressure. So I've got high pressure ocean flowing onto low pressure land in the summertime, bringing lots of wet air, very humid, over the land. And therefore, in the summer monsoons in India, you get tons of rain, to the point where there's actually regional flooding. It's expected that this flooding will happen. So you can actually see behind this statue, this river is quite flooded, but you can see they've built up retaining walls around the buildings around this area so that they are essentially dams keeping the water out. So they're prepared for these monsoons because they are expected every season, you'll either have a wet monsoon season or a dry monsoon season. And so they have to plan around what the weather is going to be like on a regional basis. So that is our local winds. I'm going to stop it here and start another one.